All right, Chapter 10, test preparation. This Chapter 10 test will have 10 questions on it. This first clip is going to cover the first 4 questions. All 4 of these questions are going to be referenced in section number 1. Section number 1 on circles involved lines and segments that intersect circles. This was basically just an introductory section that identified geometric objects. It laid the foundation for the rest of the chapter. And your first 3 questions on your chapter test, you're going to be given a diagram. This diagram that you see on the board was taken directly from our section 1 notes. Your diagram on Wednesday is going to look a little bit different than this. There may be multiple circles involved, different kinds of segments and lines that are interacting with it. But essentially, you're going to be given a diagram. There will be circles or a circle, and you're going to be asked to identify certain objects here. So the main trick with these first 3 questions is 1, being able to identify and distinguish, so, say, for instance, between the key terms that you see here. So the difference between a chord and a secant and tangent, or a radius, a diameter, whatever it might be. And in the section 1 notes, I break down each of those terms. So 1, being able to identify that object. 2, it'll be how to label that object. Okay? In each of these cases, it's going to kind of boil down to a 2-letter name for that object, and then using the correct notation. So, as far as notation goes, keep in mind that, again, this was in section 1 notes, a chord or a diameter or a radius, each of those are what we call segments. Okay, they have definitive endpoints, starting and endpoints. Does not extend off into forever. Whereas a secant and a tangent are both going to be considered lines. They extend off into forever, so that notation changes. Now, it is also possible for me to say, like, name a secant segment or a tangent segment. I'll make sure if that pops up in your test, I will distinguish between the two of you, because in that case, I am specifically asking for the name of a segment, definitive endpoints, as opposed to a infinite line. So just be aware of that notation. So anyway, let's just jump to the solutions right here. In this diagram, and here's what I want to point out the difference from our section 1 notes. In the section 1 notes, I actually gave you the name of the geometric object, and your job was to then identify what type of key term identified that object. In this case, it's the flip side of the same coin. Now I give you the key term, you identify the geometric object. So, number 1 right here, name a chord in this. And again, if there were multiple circles, I would say name a chord in this specific circle, whatever it might be. So I'll just remind you, a chord is a segment that is going to have its endpoints on the circle itself. And in this diagram, there are actually 2 different chords to choose from. The 2 chords to choose from, the first one here on the left, again, you can just, even though this is a line that goes off into forever up this direction, I can break it up into this smaller geometric piece, namely segment QP or PQ. Either way would be correct here. So I'll go ahead and use QP. Now, those would be the letters that would identify the endpoints of that chord. Now, again, just be careful of your notation. If I'm talking about a segment, it's going to have this bar on top of it, no arrows attached. So for a segment piece, if I asked you to identify a diameter or a radius or a chord, it's going to have this segment notation with these definitive endpoints, but no arrows on either side of that notation. Now, the other chord here that you could have used would have been RP or PR. This is also a chord. It is a segment with both endpoints on the circle itself. This is just also given the identification of a diameter. A diameter is a specific type of chord. So in either case, you will have options typically for some of these objects. In either case, just make sure you identify based on the term definition. All right, number 2 here, identify a secant. So in section 1 notes, we defined a secant as a line, but also be prepared, I could say identify a secant segment. Be prepared for either. All that is really going to change is the notation that we use here. So if I'm just talking about a secant line, I might identify line M to P. Okay, M to P. I could say RP and just make it a line notation as opposed to a segment notation, implying that would go on for forever in either case. But definition of a secant means that it's going to pass through the circle and intersect that circle at 2 locations. So I have a couple options to choose from here. Let's go ahead and go with this guy. I could use the actual same letters if I wanted to, go QP and just change it to a line notation as opposed to segment. Or I could use MP or PM. I'll use MP here. Again, there will be options as long as you're identifying something that passes through the circle, and I'll use a line here. But again, here's where I'll emphasize, if I said a secant segment, and I'll point this out again on Wednesday for our chapter test, but if I said a secant segment, then all that would change here is that I would change these arrows to just definitive endpoints. Okay. If I say a secant line, then I would use these arrows. All right, now for number 3, it'll be kind of a similar situation. Just pay attention to whether I say a tangent segment or a tangent line. Be prepared also, we talked about in the section common tangents, if there were multiple circles. Okay, I'll make sure I distinguish on that on the actual test day. But for a tangent, this by definition means it's some geometric piece that only touches the circle in a single spot. And particularly for a line, if that goes on for forever, it's only going to touch in that one spot. And in this diagram, there's only one place where that happens. And that's line MN or NM or MR, RM, RN. There are lots of different ways I could label this top piece right here. So if I said to identify a tangent line, I would just have to identify that piece. I'll just call it MN. There are a few different ways I could name this. But if I said tangent line, again, I would use these little arrow notations. If I said a tangent segment, that would change those arrows to just a traditional bar. So again, I'll point out those differences on your actual test date. The notation really here is just going to be the tricky piece, if you can call it tricky. It's identifying an object. And again, I'll point out in our section 1 notes at the very top, I have examples and definitions of each of these key terms as you come across them. Okay, so those are your first 3 problems on Chapter 10 test. Let's move on. All right, problem number 4 is also going to be referenced in section 1 on line segments that intersect circles. In this case, this was another problem from our section 1 notes. I'll just pull this directly from what we had. We had a circle, and we were given this triangle that interacted with the circle, and it had these labels S, T, center of the circle R, or sorry, that was P. Not that that matters. It's just a letter. It's a name of it. But anyway, we were given this triangle, and then we were told the following information here. We were told that it was 35 units for that piece. We were told this was 12 units, which, since it goes to the center, this is what we'd also call the radius of the circle. And then we were told that this entire segment SP was 37 units. And this is what we were asked in this problem. Is segment ST tangent to the circle? Is segment ST, this top segment up here, is this tangent to the circle? So let me just jump right into what the process is going to be here. This is a reference to a theorem that tells us that any object that is tangent to a circle has to form a 90-degree angle with a radius. So the only way that ST is tangent to the circle is if this angle right here is 90 degrees. And so what does that do for a strategy? That means essentially, if this segment is tangent, that's going to force this triangle shape to be a right triangle. And if it's a right triangle, then Pythagorean theorem has to be true. And so in this problem, I'm basically going to test whether or not it's true. If Pythagorean theorem works, it's a right triangle, that forces segment ST to be tangent. That would answer the question. If I test Pythagorean theorem and it turns out to be false, then simply not tangent. It's just basically a true-false check. So let me set us up with the geometric formula here. Basically, I'm going to test if each of these 3 sides is going to fit into Pythagorean theorem. So this is the geometric way to write it. And the reason I'm writing it this way is because, hint, hint, on your chapter test, I may not tell you what the whole hypotenuse is. Another way I could write this is simply to tell you the distance from S, say, to the edge of the circle. But in that case, the rest of this distance would just be that radius, because that radius has to be consistent. So I'll just add 12 to whatever that value was. So it can be presented in multiple ways. I'll make sure I point that out on the chapter test date. In this case, essentially what I'm doing is I'm testing to see whether or not this is a right triangle. And the reason why SP has to be the hypotenuse here, because remember from a previous chapter when we talked about Pythagorean theorem, this is really the only critical piece to identify, because these guys, I can swap them and it doesn't matter which order they go in. But I do need to know which one's going to be the solo guy on this side for the c squared of Pythagorean theorem. In this case, it's easy to identify because it simply has to be the longest side. But also speaking, like if I'm talking about a tangent piece, if this is forming my 90-degree angle, the side opposite that 90-degree angle, the piece going through the circle right here, has to be the hypotenuse. Okay, but now I'm just plugging stuff in and I'm going to do calculator work. So let me demonstrate that right now. So ST here, that's the questionable piece right here, the 35 units. I'm going to test to see if that's squared, plus the other leg here, the radius, 12 squared, equals the hypotenuse, 37 squared. And technically speaking, this is a question mark. I don't know whether or not this is true. It's quite possible that these sides do not equal each other. I'm testing that. So don't be afraid to use a calculator. 35 squared, or 35 times 35, is 1,225. I happen to know what 12 squared is, or 12 times 12 is 144. And then 37 squared, or 37 times 37, is 1,369. Okay, again, question mark. I don't know whether or not they equal each other. All right, simple arithmetic now. 1,225 plus 144. Look at that. Happens to equal 1,369. And I end up with this statement. 1,369 equals 1,369. This seems redundant. It's like, okay, well, yeah, duh. But what we have just solved here is we have proved that since Pythagorean theorem does work with this triangle, and I do get the number equaling itself, this is forced to be a right triangle, which in turn forces that initial angle, angle T up here in that corner, it's going to force that angle there to be 90 degrees. And why does that matter? Because again, back to the question, is that segment tangent? It can only be tangent if that's a 90-degree angle. We just solved that it was a 90-degree angle. Therefore, yes, this segment is tangent. Now, what would a not tangent scenario look like? Again, that is possible here. All that would have happened is that as I worked through the Pythagorean theorem, I would have ended up with any other number not equaling that. Okay, so had I gotten like 1375 equals 1369. Well, no, 1375 is 1375, 1369 is 1369. They're two different numbers. So in that case, it would not have checked out. And because it didn't, that would just force this triangle to be not a right triangle. Then that couldn't have been a 90-degree angle. And then in turn, the segment would not have been tangent. So essentially, in your process here, when you're answering the question, you're just testing Pythagorean theorem. If the statement makes sense, if the numbers equal each other, it is tangent. If it doesn't, it is not tangent. Simple enough. You'll also be asked to explain why or why not it's tangent. You'll just say simply Pythagorean theorem worked or it didn't. In this case, yes, it's tangent because Pythagorean theorem worked. All right, but that concludes this clip. These are the section 1 problems. We are 4 questions deep into our 10-question test at this point. In the next clip, we'll cover the next several questions moving forward after that. But I'll go ahead and stop our recording for clip number 1 right there.